In this lesson, we will learn about how VZoom relates demand matrices to demand segments and its relationship to assignment of trips to a network. To perform an assignment, you need a demand segment with a populated matrix. To see the relationship of demand segments to matrices, select Demand and choose Demand Models. On the Basis tab, we see the name of our demand model, any code assigned, and the type of demand model. The type in our example is a 4-step model, which is trip generation, trip distribution, mode choice, and assignment. VZoom also supports activity and tour-based demand model structures. The Person Group tab defines stratifications of our demand. Modelers define these when transport behavior is different among groups. Typical models may use income, auto ownership, household size, or combinations of these to define demand strata. Next, the Activity Pair tab defines the purposes of the trip. As examples, we may have commuting trips, commercial vehicles, or non-home-based trip purposes defined as activity pairs. Notice you have the option to automatically create your demand strata based on the person groups and activity pairs defined. Finally, demand strata are created, then mapped to matrices. You have the option to automatically create the demand matrices. We'll close this dialog and open the Demand Data window and select the Demand Segments tab. Demand strata are used in the trip generation and distribution stages of a 4-step modeling process. The resultant demands are combined into demand segments. The Time Series tab establishes the temporal horizon that the demand segment represents. Finally, the demand segment is assigned in the model procedures. Impedance is the aggregated delay experienced on a path. In VZoom, you have options to define how impedance is calculated. Let's see how to establish impedance for use in path building and assignment. In the Calculate Procedures window, we select the Functions tab and expand the Private Transport Functions outline on the left. Click on Impedance. This opens a dialog that displays the objects included in the impedance calculation. If the checkbox In Detail is checked, then a unique function may be defined for links, connectors, and turns. When empty, the same function applies to links, connectors, and turns. To modify the function, click on the icon that says Function. We use the Create button in the lower left to add additional terms to our function. Delete removes terms. Underneath these, we see the units of length and time. We also select the operation in the drop-down along with the attribute. VZoom allows the use of attributes such as tolls, free and constrained time, distance, and user-defined items in the advel attributes. Once we're satisfied with the function, we click OK. Now that we've tackled the impedance function, we'll move on to volume delay functions. Just above impedance in the private transport functions are volume delay functions, or VDF. This window is divided into two main areas. On the right, we develop and modify link volume delay functions. The center is where we assign specific functions to a particular link type, such as a freeway or principal arterial. There are 100 link types available. Rows correspond to the first digit of the link type. Columns, the last digit. Below these, we have options to define a function for zone connectors and if we want to consider minimum link type speeds. Click on Create to establish a new function. The dialog tells us the number of the function, and in the drop-down, we select from a number of predefined functions in VZoom. The equation is displayed in the center of the window and the parameters are entered at the bottom. For our example, we'll establish a modified Bureau of Public Roads curve by selecting BPR3. We then click in the boxes for each parameter and populate with the values to represent the time delay as a function of volume. Click OK to close the window and create the function. Cancel closes the window and doesn't save our function. Once established, we need to assign the function for the link types assigned this function. We can click on a specific cell, double-click, and then enter the number of the VDF. To establish multiple cells, we can highlight a row or column, or left-click and hold while dragging over a range of cells and enter the value in the Selected Cells box below the link types matrix. Node and turn VDF are established the same way they are for links. Here is where they are located for reference. To run an assignment, we must first establish its parameters, have a routable network, and demand model. In our example, we have a network and a demand model established. We need to create the assignment operation. Do this by going to Calculate, then Procedures, and selecting the Operations tab. In the right of center, click on Create. This opens a window with a listing of all the operations available in vZoom. The default is for an assignment. Click OK, then click Selection DSeg in the lower right. This allows us to select the demand segments we'll be assigning to the network. Once we choose the demand to be assigned, click OK, and then you notice that the procedure line near the bottom is now available. The drop-down list lets us select the type of assignment. vZoom supports several assignment models, but we will use equilibrium assignment for now. Just right of the drop-down is the parameter icon. Click on it and notice it opens the dialog to establish the parameters for our example. Beginning at the top, we can select whether we want to use the initial assignment as our starting point. We can also choose to use an incremental assignment to give us a start. This helps save time by priming the pump for our assignment. If you establish a feedback loop, the assignment result from the previous iteration is the initial assignment solution. Next, we establish termination criteria. Termination criteria allow the modeler to code the relative gap, iterations, and deviation they wish to allow in their assignment process. Last, the number of network balancing iterations are selected. If you click on this, you can set external iterations with a different number of balancing iterations. This is also helpful in speeding up the assignment process. Once all the parameters are coded, click OK, and then to operate the assignment, click on Execute.